Hey guys, welcome to Pre-Calc lesson 4.2, solving and graphing inequalities. First, we're going to review how to graph a linear inequality. In equation 1, that is solved for y already, so I can identify my slope as 3 over 1 and my y-intercept as negative 2. Now, how does this affect the graph? Well, if you remember, greater than means we're going to shade above, and since it's or equal to, that means it's going to be a solid line. I'm going to shade above because it's greater than. All right, so let's get some points on this line. We said y-intercept is negative 2. So there we go, crosses the y-axis at negative 2. My slope is 3 over 1, so that's up 3 over 1, up 3 over 1. Just continue that. If you want to reverse it, down 3, left 1, down 3, left 1, and continue that. So it's a solid line. I always check this before I sketch it in because I've seen a lot of times where you draw the line in and you're like, oh, it's dashed. But in this case, it's solid, so sketch that in as neatly as you can. And then we shade above. All right, don't think right or left. It's above or below. So here's a point and above. So all of this is what gets shaded, okay? All right, the next example, I want to use the intercept method because I notice it's not solved for y, but this number right here, a constant, is divisible by both 4 and 2. So I'll have nice integer intercepts on both the x and the y. So remember how to do that. To get the x-intercept, you set y equal to 0. So this just goes away. What are you left with? 2x equals 16. So x is 8. So on the x-axis, I'll go over 8. 1, 2, 3, 4, 5, 6, 7, 8. Put a point. So I know the line crosses there. To get the y-intercept, remember, you set x equal to 0. So this would be 0. What do you have left? 4y equals 16. So y equals 4. 1, 2, 3, 4. Right there. Now we need to figure out what this tells us. Well, because it's less than, we're going to shade below. And because it's not or equal to, it's going to be a dashed line. So a dashed line, I'm going to shade below. All right, so now to get this, because, I mean, you could use a straight edge, but you can kind of figure out, well, I had to go down 4 over 8, or basically down 1 over 2. So you can get some more points. You don't want to just kind of haphazardly sketch this in, especially when we get into linear programming. So make sure you're continuing that slope accurately across your graph. Okay, dashed, shade below. All right, there we go. So what are the steps for graphing inequalities? All right, well, first, you have to solve for y. Or we can use the intercept method, which we just learned in our last lesson. Next, we have to interpret the inequality. So what that means is if you have less than or greater than, that's a dashed line. If you have less than or equal to or greater than or equal to, that's a solid line. If you have less than or equal to, you want to shade below. If we have greater than or equal to, shade above. And then lastly, it's just more of a reminder. If you multiply or divide by negative, you have to flip the inequality. I don't think we'll be doing that a whole lot, but it's just a reminder out there with inequalities, you have to flip it if you multiply or divide by negative. All right, so let's do a system of inequalities. This is really what we're going to be doing this unit with linear programming, 3 or more inequalities. So graph the following systems of equalities, shading the solution region. The first one should be pretty straightforward. X equals 0. Remember, that's going to be a vertical line. It's actually the y-axis. This is the only time where you have to think of right or left versus up, down. Because a vertical line, you can't go above or below it. Obviously, it's either right or left. So what we want to know here is that it's dashed, number one, and we want to shade to the right, greater than. Now, one of the things that I'm going to do, first, I'll sketch in this line dashed. I don't do the shading yet, because it can get a little bit cluttered with 3 or more inequalities, and you have all these different shadings. So what I like to do is just a little reminder off the grid where I'm going to shade. So basically, I know I have to shade this region. But I'm going to have other inequalities in here, and it just kind of gets real messy, and you're like, oh, where's the solution? So just remember, for now, it has to be in this region. Okay, well, we don't have to do these in order, so the next one I'll probably tackle is this right here. Y equals x. That's a very easy line to sketch. You should know that one from geometry. And what this says is, let me use a different color, it's going to be dashed, and because it's greater than, it's going to be above. So the first thing I'll do is sketch in this dashed line, y equals x, and I'm shading above. So now I can visualize, oh, I've narrowed down my solution to this region right here. Okay, so now let's see what happens. This line, I have to solve for y. We could use the intercept method also, but I'll just solve for y. It's kind of easy. Y is less than or equal to negative 3x plus 12. So my slope is negative 3 over 1. My y-intercept is 12. And it's going to be solid. And I'm going to shade below. All right, so let me see. Can I fit 12 on here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm off the grid a little bit. So down 3 over 1, down 3 over 1, down 3 over 1. And I just keep doing that. Solid line. All right, so let's sketch that in. And I shade below. So shading this way. So now what I think is the best way to do this is just shade one region. So a reminder, I started with this, okay? Then I had to go above this one, so that narrowed it down to here. Now I have to be on this side, so my region, my solution, would be in here. And that's what I'm just going to shade in my final answer. Okay, let me stick with this green. So I just shaded the solution region. I didn't have shading going all over the place. So any coordinate in here would be a solution to this system of inequalities. Now you just have to be careful because on here would not work because that's dashed. On here would not work. Technically, on this line would work right here on that segment, but we usually want to avoid that and stick to any coordinates inside here. Okay, next one. This is a super easy one. I love doing this one. All right, x is greater than or equal to 0. And what we're going to notice a lot in linear programming is that we're dealing with real-world applications. So very rarely, especially in manufacturing, shipping, very rarely do we deal with negative numbers. So notice what this says here. X is greater than or equal to 0. Y is greater than or equal to 0. So basically what that does when you see these two, it just puts you in the first quadrant. Okay, so there's your x is greater than 0. Here's your y is greater than 0, and there's the combination. That's why when you have the option of setting up your axes, as you put the y-axis all the way on the left, x-axis all the way on the bottom, because I know everything has got to be in that quadrant 1. Okay, so I really don't do much with those for now. Then I like to do the easy ones. So next, I'll go y is less than or equal to 3. So this is going to be a solid line. Remember, y equals is horizontal, so it's going to be below. So y equals 3. Graph that line. And I know I'm going to shade below it. So I don't want to fill that in yet because I'll have some region that obviously has to be in here. Well, this other line, I want to use the intercept method for. All right, so let's take this and let's get the x-intercept. The way you get that is you set y equal to 0. So that goes away, and I have 3x equals 24. So x equals 8. All right, so 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis. Now let's get the y-intercept. So the y-intercept you get by setting x equal to 0, so that goes away, and you just have 4y equals 24. So y equals 6. 1, 2, 3, 4, 5, 6, right there. This is going to be a solid line because it's or equal to, and it's less than, so you go below. Now I'm going to sort of cheat here, use a straight edge to connect those two. And I know I need to shade below. So now we have to visualize. I'm in the first quadrant. I'm also below this line. And now I have to be below this line as well. So that is going to be this region right here. So let me use a different color to highlight that region. That polygon is the solution to this system. All right, so graph the solution region, did that. Give the coordinates of a point. So any point in here is good. All right, I'll pick, I don't know, 3, 1. Now, when it comes to linear programming, our vertices have special meanings. So we need to be able to identify those. It's pretty easy from this graph, nice integer coordinates. Label the vertices. Let's start with 0, 0, and I'll work my way clockwise. So then I have 0, 3. This one right here looks like it's what, 4, 3. And then my one on the x-axis, 1, 2, 3, 4, 5, 6, yeah, 8, 0. All right, moving on. Last one, we'll work backwards. I'll give you the picture of a solution region, and you have to come up with the system of inequalities. So this you can see is a triangle. So it's bound by 3 lines. So this one right here is dashed, and it's horizontal. So it's got to be y equals, or y is greater than or less than something. And I'm shading up. So this one I got y is greater than, and it crosses the y-axis at -1. How about this one? Pretty straightforward. It looks like the slope is 1, right? Up 1 over 1, up 1 over 1. The y-intercept is -1. Okay, so this one right here would be y equals x minus 1, and I'm shading below. So it's less than or equal to that. Less than or equal to x minus 1. And then the last one, this one here has a negative slope because I'm going downhill. It's -1 over 1. The y-intercept is 3, 1, 2, 3. So if I just write that part down first, y, I have -x plus 3, and it's solid, and I'm also shading below. See, I'm shading below there. So that's less than or equal to. So your solution is you have to write all those as one system. It doesn't really matter what order. So I'll start with y is greater than -1. Y is less than or equal to -x plus 3. And then the other one, y is less than or equal to x minus 1. Okay, and that represents the system of inequalities that will give us this solution region. Notice the bottom is dashed. All right, guys, that concludes Unit 4, Day 2. As usual, reach out if you have any questions whatsoever. Thanks a lot for watching, and we'll see you in class soon.